A hypocycloid is when you have a circle and you have another circle inside of the first circle, and you take a point on that circle and we roll this smaller circle around. Maybe it goes counterclockwise, the center of the circle does, and we end up with something like this happening. And sometimes it overlaps, sometimes it doesn't, but if it doesn't overlap, it makes a pretty neat looking picture, and famous spirograph toy is based on this idea. Well, I'm going to show you how to find the equation of a cycloid. We need to know the radius of the big circle, the radius of the small circle, and whether the small circle is going around counterclockwise or clockwise. That's all we need to know. But I'm going to do another question first, where we need to know 5 pieces of information. Here, I don't have a rolling circle, but it's floating. The reason I like a floating circle is that we have a lot of control. I could tell you it's going counterclockwise, or it's going clockwise, or it's spinning fast, or it's spinning slow, where if it's actual hypercycloid, we don't have that much control over. I'll just go with the 10 and 2 that I've been using. And I'll tell you that the circle is going clockwise, and I'll tell you that the point on the circle is going counterclockwise. And I'll tell you that it's 5 degrees, a 5-degree rotation for each 1 degree the circle goes around the center of the other. So my set of equations, the path of the center is just going to be 10 cosine t, 10 sine t. But the path of the point on the circle, well, that's going to be 2 cosine negative 5t. Negative, the 5 because of this 5, and the negative because it's going clockwise. And that's the equation for this sort of floating circle example. So here's going to be my hypocycloid. And I'll make it as I've been doing with this thing has a radius of 10, this has a radius of 2. They have to tell you, one other thing they have to tell you besides the radii, they have to tell you whether the circle, the rolling circle, is going clockwise or counterclockwise. I'm going to make it go counterclockwise. Now, a thing that's not like so obvious is that when the circle's going counterclockwise, in order for that to happen, like the circle's kind of going, I don't know how to, circle's kind of going that way. In order for that to happen, the point on the circle has to be going that way. So it goes without saying that if the rolling circle on the inside is going counterclockwise, the point on the circle must be going clockwise. So the center of the circle is actually going around a smaller circle of radius 8, 10 minus 2. So that's why I have plus 10 cosine t, 10 sine t. That takes care of the circle going itself counterclockwise. This is plus t because it's going counterclockwise. Now on the circle it's 2 cosine, 2 sine, and it's going to be negative. Maybe there's a coefficient here. We'll take a look. So a smaller circle, the smaller the circle inside, the more sort of times it goes around. And it's dictated by the ratio of the 2 radii, so 10 over 2 equals 5. But we're not done, because let's go again with that 40-degree thing from before. Actually, let me clean this up a little bit. So here's the circle. This red point is like the horizontal point. It's also the point that's going to be moving. Here's the 40-degree. Here's the circle again after it's moved 40 degrees. Here's that red point. It will be over there. Here's the point on the circle, making some kind of shape like that. Now after 40 degrees, this red point rotates 200 degrees. So it kind of ends up over here where the green point is. If it was standing still in the spot but just rotating at the same speed. Well, that 200 degrees, sorry, it wouldn't be 200 degrees, it would be negative 200 degrees because it's going clockwise. Well, that negative 200 degrees is over here. But the thing is, since this red point is now over here, that 200 degrees, oh, I realize, by the way, that my first 200 degrees should be kind of over here because it's more than 180. But it's not actually in this spot anymore. It's actually over here. It's moved counterclockwise because this red point here is no longer horizontal. So yes, there is a 200 degrees thing, negative 200 from here to here, but because this red point is now over here instead of over there, where it originally was, we have to add 40 degrees to make up for that. So it's really located at negative 160 instead of negative 200. And you could actually see, if here's negative 200, this is like counterclockwise from it by 40 degrees. That's why, just like in the epicycloid, we need an extra plus t here to compensate for that. It has to do again with, here's another, I'll make it yellow. There's that, that's the 40 degrees. So that kind of gets added to the angle. I mean, it's 200 minus 40 is 160, but this is really negative 200 plus 40 becomes the negative 160, which is where this thing is. So for hypocycloids and epicycloids, if they're going if the circle's rolling counterclockwise, you must have a plus t here and here. The 5 is dictated by the ratio of the two radii. This minus is because the point on the rolling circle goes clockwise when the circle itself is going counterclockwise.